We think we understand stars. They burn steadily for billions of years, their brightness changing only in predictable ways, like a planet crossing their face. But in 2015, citizen scientists flagged a star that broke every rule. This star, officially named KIC 8462852, dims by up to 22%, far more than any planet could cause. Its dips are irregular, lasting days to weeks with no pattern. Astronomers had never seen anything like it. And there's more. The star has dimmed by about 3% over the last century, a slow fade that compounds the mystery. This is not a planet. This is not a sunspot. This is something else entirely. In 2009, NASA launched the Kepler Space Telescope on a simple mission: stare at a patch of sky and watch for the tiny, periodic dimmings that betray a planet crossing its star. It found thousands, but one star broke the pattern. So when citizen scientists scanning Kepler's data in 2015 flagged a star that dimmed by up to 22%, far more than any planet could cause, they knew something was off. They called it KIC 8462852. Lead researcher Tabitha Boyajian published the findings in 2016. The light curve showed dips that were irregular, deep, and unpredictable, nothing like the neat, periodic transits of planets. This was something else entirely. So, what makes the dimming of Tabby's star so impossible to explain? The Kepler Space Telescope recorded dips in its brightness that reached 22%, far more than any planet could ever cause. That's like a star suddenly losing a quarter of its light, an event that defies all known stellar physics. If a planet transits a star, the dimming is periodic and tiny, usually less than 1%. But Tabby's star dips irregularly, by enormous amounts, with no pattern at all. That alone ruled out a planetary explanation. But the strangest part came later. Astronomer Bradley Schaefer examined historical photographic plates and found that the star had dimmed by 3% over the past century, a slow, steady fade that no known stellar process could explain. These two puzzles, the deep irregular dips and the century-long dimming, cannot be explained by any single cause. As the astronomers wrote, the star is doing something that no other star does. And that left only one question: what could possibly be causing it? So why did the most extraordinary explanation capture the public imagination? The idea was simple. What if the dimming was caused by a vast alien structure, a Dyson swarm built to harvest the star's energy? In 2015, astronomer Jason Wright suggested that a swarm of orbiting collectors, like a Dyson sphere, could cause the irregular dips. The media latched on, and Tabby's star became the alien megastructure star overnight. But as Tabitha Boyajian herself said, the alien megastructure hypothesis was always a long shot. It was a scientific outlier, yet it sparked a wave of public curiosity and drove astronomers to take a closer look at this baffling star. So, what could cause such impossible dimming? The most sensational idea captured the public imagination: an alien megastructure, a Dyson swarm built by an advanced civilization to harvest the star's energy. It was a thrilling thought, but science demands evidence, and the evidence soon arrived. When astronomers pointed the Spitzer and Sophia telescopes at Tabby's star in search of infrared heat, they found nothing. A Dyson swarm or a massive dust cloud would glow in infrared, but the star showed no excess. The alien hypothesis was ruled out, leaving astronomers back at square one. And SETI searches for artificial radio signals from the star also came up empty. As Tabitha Boyajian later said, The alien megastructure hypothesis was always a long shot, but it got people excited about science. The mystery remained, but now it needed a new, more mundane explanation. So, what could cause such bizarre dimming? The leading hypothesis points to dust, uneven clouds of fine particles from a disintegrating comet or asteroid swarm. In 2018, Boyajian and her team found that the dimming is wavelength dependent. The star fades more at shorter wavelengths, exactly what you'd expect from dust, not solid objects. But here's the problem. If a large dust cloud were causing the dimming, it should emit infrared heat. Observations from Spitzer and Sophia found no such excess. The dust must be very fine, micron-sized, and only present during the dips, not as a permanent ring. This makes the comet swarm idea plausible, but far from proven. And that's why the mystery endures. The dust hypothesis fits the data, but it cannot explain the century-long dimming or the lack of infrared glow. As Boyajian herself put it, the most likely explanation is that we are seeing a swarm of comets or a cloud of dust. But even that leaves astronomers with an unsettling feeling, like knowing the answer, but not the whole story. So the dust hypothesis works for the short-term dips, but it leaves a deeper puzzle unsolved. Why has Tabby's star been slowly dimming for a century? And why do we see no infrared heat from that dust? These questions remain unanswered. One possibility is that we're seeing multiple dust sources, perhaps a family of disintegrating comets on different orbits, each creating a temporary cloud. But that still doesn't explain why the star has faded over decades, leaving astronomers with more questions than answers. But if comets are the cause, they must be enormous, thousands of them, each the size of a mountain, and they'd need to orbit in a chaotic swarm, not a neat ring. That's possible, but it raises another question. Where did so many comets come from in the first place? Another idea, maybe the star itself is unstable. Some stars have magnetic cycles that affect brightness, but Tabby's star is an F-type main-sequence star, not known for such violent behavior. Still, a massive star spot or a stellar flare could cause dimming, but not the century-long fade. The century-long dimming is the hardest piece to explain. It's too slow for a stellar cycle, too steady for a random event. Some suggest the star is consuming a planet or a brown dwarf, but that would release energy and make it brighter, not dimmer. The dimming points to something blocking light over decades. What if the star has a tilted ring of debris, like Saturn's rings, but enormous? A ring could cause irregular dimming as it rotates, and over centuries it might slowly precess, changing the amount of light blocked. But a ring would emit infrared heat, which we don't see, unless the particles are too small to glow. Astronomers are now monitoring Tabby's star with multiple telescopes, waiting for the next big dip. When it happens, they'll observe in real time across wavelengths, infrared, ultraviolet, X-ray, to catch the culprit. The key is to see the dimming as it happens, not just in hindsight. And you can help too. Projects like Planet Hunters and the Boyajian Star Campaign invite anyone to analyze light curves. Citizen scientists have already made key discoveries. The next person to spot a clue could be sitting at home, scrolling through data on a laptop. So after all this, the big question remains: what is causing Tabby's star to dim? We have plausible ideas, but no definitive answer. It's a reminder that the universe still holds secrets, and sometimes the most ordinary explanation, dust, can be just as strange as an alien megastructure. And that's the heart of the mystery. Even after years of study, Tabby's star continues to defy explanation. As Tabitha Boyajian said, the star is doing something that no other star does. Perhaps the next telescope, or the next citizen scientist, will finally reveal its secret.